energy, and then we can get into safety after, with the accidents, how this will save lives. I think we got into the cost per mile. Did we get into that?
Well,
Yeah.
it sort of would be your example, right?
Right.
We used to say 10 years or so ago was 10 million a mile for two-way, elevated. But construction costs have gone up. I used to know from when I was actively building things pretty well how to cost estimate, but I don't. I just know there's a lot of inflation. Our friend Bud is at Poly, puts numbers into that, which are, what are that, 25 million a mile or something?
25 million a mile, yeah, right.
Yeah. And
But that's exclusive of land purchase, the reason.
oh yeah,
And that's,
you're quite right.
and that's because and if you had to purchase land, it would be more, a lot more. But if you go along the right of way, that's for free.
That's right.
Okay, so do you want to first touch on like the energy and
Yeah, it would be great if you guys could like make some statements moving forward on different topics, kind of hit some headlines. For people, I just want people to get a good visualization of what needs to get done or why we need to do this, so on and so forth.
yeah, so okay, so I could first say, why do you think this is needed for Long Island? Why is this
Yeah,
technology
that's great. Yeah.
Okay, and then
We're already rolling, so you can
Okay.
you can just start whenever you feel comfortable.
It'd be much cheaper and much faster and get the trucks off the
We're,
road.
we're doing now?
Yeah,
Yeah.
well, you could formally start in like in a
Okay.
second if you want to just
Yes.
re-present the question.
Okay, so why is the maglev technology needed for Long Island?
Well, I think that it's needed because it'll, take trucks off the road in the IE. That's already been identified as a severe problem. It's going to get a lot worse in the days ahead. Second is that people need to get to work at reasonable cost and reasonable time. And we know that the Long Island highways are getting more and more congested. And we know that oil prices are going to go way up. So it's going to take a bigger and bigger bite out of people's pocketbook. I mean, a large part of your cost of driving is the fuel.
Yeah,
It's
today.
yeah. I mean, it's just that. I mean, it amounts to 20 cents a mile for fuel, and so by having people to travel quicker on maglev, Long Island, adapted Long Island, the Long Island Railroad adapted for maglev travel, be able to travel quicker to their places of work at lower cost, which will help people's incomes on Long Island and standard of living and so forth. Pay less taxes. That's right.
And greatly reduce the number of trucks and cars on the expressway. I
Right.
mean, nobody's going to forbid them to go there, but we don't want that either. But the fact is, most people would quickly learn that they'd be stupid not to change.
And it will reduce highway deaths and injuries.
Yes, that's very expensive.
Yeah, the
I got dehydrated a month ago and went in to the Riverhead Hospital, which is pretty good now. And I got 2 bags of water, basically, and a lot of questions. And then they sent me home, and my doctor came along and said that. And the bill came to $3,000 for just occupying a room for, it was maybe 7 or 8 hours and getting some attention, but it really adds up.
right. So if you get injured and spend days in the hospital, that's tremendous.
Hundreds of thousands.
Tremendous burden. I think those are the big.
And the fuel, as Jim said, because obviously we can make electricity And we can
Right.
store electricity too, if anybody listened to that. But since we can go up steep grades with very efficient propulsion, we can carry, Jim did a study on this, we can carry big rocks up to, say, a half-mile high hill up north. And then when you need the power, it turns into a generator, comes back down at peak time. I mean, most power plants are fed by gas or oil or something, and they're damned hard to turn off and on quickly. And so they tend to waste power when nobody using it. So that's another
And another really good benefit of this facility on Long Island, of bringing maglev to Long Island and testing it and so forth, is that I think we can get some really good manufacturing industry on Long Island.
Right.
and
Yeah,
jobs.
we'd be the Detroit of maglev,
Right.
right here.
You
And it was
know,
invented here.
There'll be, wherever you build maglev, there'll be construction jobs, like making beams and transporting beams and so forth. But much of the, you know, a significant part of the money that goes into making or producing the maglev line will be like making the magnets, for example, or making the guideway panels. And I think we could have industries on Long Island that would do that,
That's
do
right.
it very well.
That's
And,
right.
I mean, Long Island really benefited when Grumman was here. I think we could recreate that kind of industry again on Long Island.
That's not even as high tech,
Yeah.
so
And so,
clearly do that.
yeah. Plus being a tremendous tourist attraction, I think
Yeah.
that would be a neat thing.
So what are the speeds that it would be able to reach?
Oh, on Long Island, the facility would be doing two things. One being to test it on railroad track type of things. There I see the top speed being about 100 miles an hour. That would be very energy efficient, because at air drag at 100 miles an hour is a heck of a lot less than
Practically
at 300
nothing.
miles an hour. It goes as the cube of speed. So something 3 times faster is 27 times as much power. But we would also test a section of elevated guideway, maybe 2 miles long, and you'd get the vehicle up to a speed of 200, 250 miles an hour, and then you'd have to
Immediately
immediately
stop, slow down.
start slowing it down, because you don't want to run past your 2 mile or 2.5 mile point at the end of the guideway. So, but we would be able to demonstrate the high speed thing, but not to run it, would not be able to run it
Continually.
continually, because we'd have to accelerate, reach a speed, and then almost immediately start to decelerate, and then do this again, and so forth. And so the next phase, I don't see being built on Long Island, because it would just have too long a track, and that's why I was referring to the New York Thruway being part of the test program, where we build it, say, a 25 or 30 mile section along the Thruway, say between Tappan Zee Bridge and Newburgh, which will eventually become part of the
National
route
system.
from New York City to the 4th major jet port at Stewart. So that you could run continuously with an end loop on each end, and so it would just go around and around and back and forth, and run it for days and weeks at a time, proving that you had that capability. But also, when you think about it, building along the Thruway has enormous benefits for New York State and for Long Island also, because be able to go all the way from New York City north to Albany, then you join the Thruway going west to Chicago, through Toledo and so forth, Cleveland, and
East
go
of Boston.
east of Boston. So a large fraction of the highway traffic in the northeast would travel on Maglev along this corridor. And a lot of that traffic would come down to New York City. So we wouldn't have lots of trucks coming down across the Tappan Zee and the other bridges. Just come right down. And then part of that traffic would naturally flow into the Long Island Railroad. That truck traffic and passenger traffic would naturally flow into the Long Island Railroad to be brought out to anywhere it was destined to go on Long Island.
Mhm.
So we could see that happening also. So shipping out things from Long Island and getting things into Long Island would be a lot easier than it is now.
Yeah, if they wanted to go, I agree with what Jim just said, but I mean, we could, at least we've talked about, after we did the work on the spur that goes into Calverton, we could run to Ronkonkoma, because east of there, there's not much traffic anyways. It wouldn't inhibit anything for a while we're getting all this going.
Right.
Or we could go east.
Right.
But there's more impact, as he said, with going from the city and starting north. And
So this technology would be safer than an airplane and also more efficient, and it would cost less.
that's right.
Well, airplanes are pretty safe.
Right.
Yeah, it's the highway that's
The highways.
really the problem.
Right.
I think we could certainly do as well as airlines, and maybe a little bit better, but there aren't very many airline disasters, as you know,
Right.
and I think we would
If they keep flying them in a condition of fatigue, that'll change.
The one advantage I haven't mentioned about the Maglev is that it is an all-weather system. You don't get stuck like you did in Florida.
Right.
You can travel in any weather,
Wow.
snow or ice or storms or anything like that.
Even we could
We
even go
designed
through-
the vehicles in the guideway so that it would take, even if you were traveling in a hurricane wind, you wouldn't derail you.
Really?
Yeah. So and ice and snow won't, because you're off the track. You know.
Right.
And it's not got contact points like the present railroad where
It
it gets
doesn't have
snow
third,
and
doesn't
it
have third rails that fill up with ice and snow.
fill up with ice and snow. I mean,
Right.
this transforms through the air. Doesn't matter whether that crap is there or not.
So it'd be a lot more desirable for travelers than airplanes. Also, a lot more comfortable. It'd be more like sitting in where we are now in the living room than sitting. When I take airline, my knees are always up against the seat. You know.
Well, that's why to make it cheap, they have to jam you in because it's so
Yeah.
inefficient. It takes so much fuel.
And when you go to the restroom, you have to get the person on the other side to stand up, and you travel down this thing. Got the bumpiness and the engine noise, and it's awful.
It's miraculous that they work as well as they do.
And then they come offering you peanuts. I mean, if you're sitting in a more first class type of thing in a Maglev vehicle, you at least get something
Yeah,
better.
because
than
since it's cheaper
yeah.
and more efficient, I mean, you can afford, as Jim says, to let people have treatment like first class
Right.
Right.
instead of sardines.
Right.
As far as safety, you know, it's very safe because okay, you say the power goes off, which doesn't happen very often, but it's not impossible. But if the power goes off, since it's driven by the alternating frequency which is normally 60 hertz in power lines, you can vary that for your own control. And then you go along, and if that went off, you'd drift, because as you go a little slower, coast, the inefficiency of the air gets less and less, so you can go 20 miles or something to where there's a designated place to
To get off.
get off.
Yeah,
And if it's elevated, it's hard, other than sabotage, to see, there's no level crossings.
right.
So,
Oh, I think it'd be tremendously safe, and as Gordon and I like to make the analogy, it's like travel. The maglev vehicle is like the fuselage of a jet airliner, but instead of having 2 or 3 engines pushing that fuselage, you've got 16 so magnets on the fuselage which are providing your lift and propulsion. And so if 1 or 2 of them fail,
Right.
no big deal, it'll just keep going. You could even have half of them fail, which would be incredibly
it's
unlikely.
like an 18-wheeler where it blows one tire,
Yeah. And so,
spread it around.
it's very safe, a lot more comfortable than airlines, and well, it'll be about the same travel time. I mean, airlines
Go 500 or
500 miles an hour, but by the time you get
something. The
off
end
the ground
effects.
and land, which is lower speed, and you go through security, and you drive to the airport, which is usually a big deal, you end up, I think, maglev would actually beat
Probably faster.
airlines from going from New York to Chicago
Yes.
from the time you left your house on that basis. They might tie when you're going cross country, might be the same base. But again, a lot of airlines, when you go cross country, you have to shift flights.
Right.
Yeah,
Yeah,
Direct.
delays.
right.
Tell us a little more about the energy efficiency of the maglev.
It's not got any friction, mechanical friction. It has air friction. So what we find is that maglev per passenger mile at 300 miles an hour is considerably more efficient than an airliner or traveling on a car, and per passenger mile energy efficiency, maybe a factor of 3 or 4. So it's more efficient. But if you try to go over 300 miles an hour,
And rapidly go down.
then its efficiency would rapidly go down. If
But,
you go less than 300 miles an hour, it becomes very efficient.
I mean,
I guess the best way to think of it is, I don't know if you're acquainted with the concept of lift-to-drag ratio. In other words, an airliner has a drag, has a lift ability which is 15 times its drag force. The drag force causes the energy. So that sets your energy requirement because you have so many pounds to lift, and then that causes, you divide that by 15, and that gets how many pounds of drag. That tells you how much energy you use. But a maglev vehicle,
when you're going up, you have to provide the bigger number,
yeah, and now
and you can throttle back.
But a maglev vehicle traveling a couple hundred miles an hour can have a lift-to-drag ratio of 100 to 1. So it has less drag than an airplane, considerably less drag.
And at 100 miles an hour, the Suburban would be very low.
Yeah. So that's
3 cubed from
yeah.
the first number.
But so that's the story in maglev. And it doesn't burn oil, which is really great because oil is going to go up tremendously. We're living in sort of an era where you know oil is per barrel has plateaued at about $100 a barrel. And production has plateaued. The world produces 30 billion barrels of oil a year. But for every barrel, 10 barrels we burn of oil, we only discover another 4 barrels of oil.
Wow.
So, it's like writing more checks and
Yeah.
have money
Whether it
in the
runs
bank,
out,
eventually you run out of money.
whether it runs out
So-
in 20 or 10,
But
10
worse-
years or 40
worse-
years, it's going to run out.
Worse than that is that
Pollution.
other countries are starting to take a bigger and bigger share of the oil, and they're going to outbid us. Like China's traffic, highway traffic is, I think, rising 18% per year. Our traffic is hardly rising at all. And so they're going to start
Major.
paying more and more for oil than we can. So the oil price being fixed in production value amounts will start climbing rapidly because they'll out doing this. Of course, they may not be able to go anywhere. I mean, there was, I guess, this story a few months ago where they had a truck jam on the highways in China outside of Beijing. They were stuck for several days. They had so many trucks.
Well, at least I'm sure their unions are more compliant.
Anyway, so the point I wanted to make was that we are paying $4 a gallon now, and that's 20 cents a mile if you have a 20 mile per gallon car. If gasoline goes to $8 a gallon like it is in Europe, that's 40 cents a mile.
Wow.
We would be paying to drive. We
Very
drive
right.
10,000 miles a year.
Right.
That's a lot of money.
That is a lot of money.
And
It
we
it
can't
just
afford
can't
that.
go on.
Yeah.
And,
So-
and whereas the electricity we can even,
Yeah, electricity is a lot cheaper.
yes, even now, and we
Yeah.
can generate that, as we just mentioned, by using maglev energy storage
Right.
and delivery, and combine that with big base power plants or solar. And I don't think those things are very efficient, although I have some on my own roof. But they only work. The reason I bought that, it cost $43,000, but after I got money mainly from LIPA and a bit more from both governments, state and federal, it only cost us $15,000. And it certainly pays at that thing. But if everybody in the world wants to get a government break, it's no longer useful to the utility because it gives them excess power for those 2 or 3 weeks in the summer, which they need another power plant for. And that's why they do it. And it makes sense. But everybody can't get in on that. So,
And, we're, right now, our transport systems are traveling down a path which is not gonna be sustainable. And I think a lot of people recognize that. It's the oil crunch and the oil cost is a problem. People talk about biofuels, but right now we use 40% of our corn crop to make ethanol. And you can't drive on the ethanol from our farms. It's just not going to work.
it's not efficient. And that's, well, even environmentalists know now
Yeah.
that ethanol is basically a fraud, but
Right.
it's established, and like everything that involves government money and so forth, the people who are making that stuff scream like hell if you say you're on your own,
Right.
because they wouldn't make it on their own.
Right. And you can make synfuels from coal and oil shale and the tar sands like in Canada. But the environmental consequences are terrible. To make We already put out 2 billion tons a year from our cars' exhausts of CO2. Worldwide, it's maybe 4 times that, almost a third of what our total greenhouse gas emission is. If you make the oil for cars and trucks from coal and tar sands, you double the amount of carbon dioxide that goes into the atmosphere. So we already know the effect is happening on climate warming and so forth, causing a lot of problems, droughts and stuff. But they're the two big problems that people don't want to seem to recognize. They're two big problems. One is ocean acidification, because as the more carbon dioxide comes out, it goes into the ocean. And I proved this experimentally. Once the acidity, carbon dioxide gets up to a certain level, the ocean is getting more acid all the time. Things that have shells on them can't form.
Yeah, that's the one I take most seriously.
Because that
Some of the
means
rest is
that
debatable.
the whole
That's-
chain of food chain in the ocean depends on little things having shells, like krill and cocoa licophores, and they eat various other things, eat them, and then they eat them, and so forth. So if you have too much acid in the ocean, the shell dissolves as fast as it forms.
Right.
So a lot of the ocean species would die, and that would be a disaster for the planet. The other is that
The human part of the planet.
When Gordon and I were awarded the Franklin Medal for our work in superconductivity, it was back in 2000 AD. The Franklin Medal is a very prestigious medal. I mean, Steinmetz got one, Tesla got one, Einstein got one, all sorts of well-known scientists have gotten it. So, but anyway, the guy who got the Franklin Medal for biology was a biologist who had done work, and he'd shown that the carbon level in the ground in Canada alone, because decay, the organic matter stored in the ground there, was greater than all the carbon dioxide in the whole world's atmosphere. So once that heated up and its permafrost is melting and decaying, and that stuff comes out automatically. You can't stop it. And also there's 10,000 billion tons of methane in as hydrates on the ocean beds. And as the ocean warms up, that stuff becomes unstable too. And 200 million years ago, 95% of the world's species were wiped out when volcanoes put enough carbon dioxide into the atmosphere that it caused the oceans to warm, and then this methane started coming out and further warmed the atmosphere. It was like a runaway warming. And 95% of the world's species died. So at some point, if we don't stop putting carbon dioxide into the air, the oceans will become too acid, there'll be runaway heating, and most of the life in the world will die. I don't know when that'll happen.
Overpopulation will do it, but these are young ladies and gentlemen, we don't want to give them all this gloom.
But I mean, it's something that MagLab addresses in the sense that it reduces the amount of
Crap we put off.
crap that we put into the atmosphere, and that really helps. So we see a lot of benefits from it, and no real negatives that I can think of.